All right, welcome everyone. We're going to go ahead and get started. So thanks very much for joining Xometry's webinar today on tackling tolerances and drawings for machined parts. First, let me introduce myself. I'm Serena and I'm on the marketing team here at Xometry. I will be your MC. Couple quick notes before we get started. Please submit your questions throughout the webinar in the question box for your presenters to answer at the end and throughout the webinar. I'll be monitoring them as they come in, so please feel free to submit them at any time. After the webinar, we'll send you a webinar recording for you to rewatch or share with your colleagues, and please stick around to the end for a special discount code just for our webinar attendees. Now, I want to introduce your first presenter, Greg Paulson. Greg is the Director of Application Engineering here at Xometry. You may have seen him in various engineering videos, on industry podcasts, and in multiple think pieces. So he's spent over a decade working with engineers on custom manufacturing projects using CNC machining, additive manufacturing, sheet metal, urethane casting, and injection molding. Prior to Xometry, Greg worked in product development with a focus on ruggedized electromechanical systems. Next, we have Mark Gallagher. Mark is Xometry's Director of Engineering Operations, and last year pioneered a new Xometry office on the West Coast focused on supporting aerospace and defense clients. Mark's day-to-day is working on the pre-sales, quoting, and operations management of complex machining projects, typically in aerospace. And finally, we have Steve Zimmerman. Steve is a partner tech support specialist and a quality supply engineer here at Xometry. He has over 30 years of experience in complex machining, including form grinding, wire and RAM EDM, tooling, and die cutting. He's an integral part of our partner hotline, assisting partners with complex projects, machine setups, and any problems they may run into while manufacturing quality parts. Steve has specialized experience in aerospace machining and was the lead programmer for a large aerospace company in Baltimore prior to Xometry. So welcome, guys, and I will pass it over to you now.
Awesome. Hey, thanks so much, and everybody, thank you so much for attending. This is a very cool subject, very cool presentation, and I think Xometry, we have a unique perspective on this because we are this platform for just a huge diverse nature of manufacturing, whether it's prototype or fully spec customized developments. So today we're going to focus on a lot of stuff that we've seen and a lot of questions that you asked when we sent out a little survey along with this webinar invite. So we have a lot to cover, and I'll be very quick going through this agenda and some of this upfront stuff about Xometry, because I do want to frame out like why we talk the way we talk and just the diverse experience that we have. So today we're going to talk a little bit about Xometry, but we're going to get into general tolerances, what we consider those standard tolerances are for CNC machining. And then we're going to go into the specific tolerance guidelines and questions that you asked today. The truth is, though, is, you know, we have some really, really awesome people on today at this webinar. And frankly, like we could do a month-long session where you could just answer these guys' questions. I was talking to Steve earlier. I was like, we call it Steve dating. We just keep on sending different people to you for 5 minutes at a time. But please feel free to use the question box, the GoToWebinar features there. Ask some questions as we come along. We're going to try to cover as many as we can. So why do we handle so many parts, so many spec manufactured parts? Well, Xometry has a very simple dashboard for uploading and specifying custom manufacturing. So we take a 3D model that you've designed. You can get it quoted online. You can just keep on specifying things like tolerances, features, finishes, and then you buy it. You know, it's a very e-commerce experience. So we take a lot of this complex back and forth from an RFQ process, and we simplify it to you're just working with Xometry and have a very customizable, very feature-rich site to work with. And we work with small business manufacturing. So Xometry has a vetted manufacturing partner network all across the United States, and we even have international options as well. that we're able to utilize their talents, their feature sets, what they can do best, and we pair them with that work they really like to do. So we're able to assure quality, great lead times, great pricing, and this distributed manufacturing through our vetted partner network. And it all starts, on this Xometry platform. So because we want to go into these questions, I won't run to the main site here, but you can see my little GIF at the end here. You could quickly upload your 3D file, put in things like CNC machining, 6061 aluminum, or 7075, or 4140 steel. Change your tolerances, features, finishes, bag and tag, COCs, ITAR. You can select that all directly on the site and press go. And most of the time, you're going to see a price and lead time update in seconds. Something to note too is if you are a designer, we do have add-ins with these same feature sets for an inventor, and we're also will provide instant pricing for things like on the Dassault systems like SolidWorks, the 3D Experience Marketplace. So you may have heard of us from there as well. And we do a lot. So today, it's machining, and we are going to graze over a lot of really cool topics on machining and tolerances today, but we also do sheet metal fabrication. We do plastic and metal 3D printing, so 7 types of 3D printing processes are available for instant pricing right now on Xometry site. We have urethane casting, and if you need to scale a product up in plastic, injection molding is the way to go. So we have a very robust injection molding service as well. But yeah, that was as quick a spiel as I could get there. So let's start talking tolerances. Let's talk about what you're all here to learn about today. In particular, this is going to be about how us as your manufacturer, interpret the drawings and help answer some of those things about how you could specify in a way in which your communication is heard on the manufacturing end, whether it's reading drawings or specifying through Xometry site here. So we have a lot to talk about. And first off, why do we put tolerances in the first place? My CAD says 1 inch. Why is my part 1 inch, right? So there's variation in the real world. Everything that you're designing, for the most part, unless it's in a movie, is there to physically exist. Tolerances are dictated by many different things, including the process in which parts are manufactured. But they identify that range that is acceptable for your part and its function, so that that variation of range. When we talk about the phrase tight tolerances, we're talking about a range of that is actually below what we consider general for that particular manufacturing process. So for every single manufacturing process that we have a list of general tolerances and guidelines that help you understand what you should expect if you didn't tolerance anything. I actually have on this slide here what we have listed on our manufacturing standards page for CNC machining. These are not tolerances that we made up out of the blue. These are industry acceptable tolerances. These are ones that would be accepted across multiple customer bases, including some of our major customers: BMW, NASA, GE, Bosch, Dell, and they're accepted by manufacturers alike. So these are relatively agreed upon. For the most part, with CNC, the general guideline is plus or minus 5 thousandths of an inch. So that's about the thickness of a sheet of paper. So again, if I upload a file, just the CAD, and press go, that's going to be my general assumption. This table here is talking mostly about as parts get longer, there's a little bit more wiggle in tolerances, and that's just the nature of big metal, big broad parts being made. Same with angularity, which is just that wiggle in deflection as well. When you're writing these basic tolerances, so the distance from one thing to another, you're usually using bilateral, unilateral, or limit tolerances. When I say plus or minus 5 for our general tolerances, that's a really good example of a bilateral tolerance. Limit tolerances are basically another way to interpret that that is more inspector friendly. So a limit tolerance is usually used as like 100% critical inspection, and we'll do that in our in process. We'll take a caliper against it, and I'll say like, hey, it's between 620 and 630. So that is acceptable, which is an easy way to interpret that, but it's kind of meaning the same thing. Unilateral is usually defined when there's a stop point, like I am a drawer going into a cabinet. You know, I cannot be bigger than the hole for the cabinet there. You know, you may have a unilateral tolerance saying I cannot go beyond this level. So usually it's a plus zero minus something or the reverse of that. So I'm bringing that up because, yeah, and Mark, hey, right on cue. I was going to say, we have these tolerances, right? But that also can translate in the CAD sometimes as well. So I know you look at a lot of CAD, you look at a lot of drawings, and we have some guidelines to help just as a general rule, like how do you prep that? Like what is the best practices that we've seen at Xometry? Oh, Mark, you're muted.
All right.
There we go.
Off to an auspicious start. Okay. So absolutely. And Steve, if you want to chime in on anything here,
Yeah.
I know this is your domain as well, feel free. But you know, in general, there's kind of two purposes for your drawing. One is to convey the design intent of your drawing, and one is to convey all of the requisite manufacturing information as well. And sometimes those two things are a little bit at odds, and we see that especially with situations where you have unilateral tolerances, for example, like you know, you're sizing a shaft or something like that, and you want to make sure there's clearance. So maybe the nominal shaft size is 1/4 of an inch, but the hole it's going into might be sized exactly at 1/4 of an inch as well. So you really want, like, you know, maybe the max size that is acceptable is really 0.248 inches or something like that. If you modeled that to the nominal of 250 and then put a unilateral like minus tolerance on the drawing or something like that, that's a good way to convey the design intent, but it's a little bit of a trap for our manufacturers. Almost always with the advent of CAM and CNC machines, the operator is programming directly off of the 3D model. So they're going to see that the nominal size is 250 on that shaft, and they're going to machine it. And you know, if you do have that unilateral minus tolerance, it could result in mistakes. So in general, for manufacturing, the best practice is to model exactly to the nominal, or more exactly the middle of the tolerance band that's acceptable. Steve, I'll let you kind of add some more context there.
Yeah, correct. Especially when you get into like complex, you know, CNC mill parts, lathe parts. Sometimes you'll have a plus tolerance and a negative tolerance in the same part. And that becomes a problem with programming and on the manufacturing standpoint, because some of the same tools are used to produce different features. So say you got a feature that's got a minus and a feature that's got a plus. We can't just go in and use the machine settings to adjust those tools. We'd have to basically reprogram it, put different tool paths in. So best practice is just try to model nominally.
Yeah, and that's it really is it's a safety measure, right? So like we are going to be looking at interpreting, and what this really does is it prevents a what you call an oops moment, where you have to go back, you scrap a part, and you make this again. So that's what this really helps doing, because we are going to be inspecting these parts to your drawing, and usually again those unilateral tolerances are the biggest I say the biggest reasons why you should be modeling to those nominals whenever you have that moment. And just in general too, on the drawing side, I know we talked about Xometry standard tolerances. Title blocks are your friend, and so usually you have a I think actually maybe I have a slide coming up here to kind of show that, but because we are programming off of CAM, we're programming after your CAD. We're using a CAM program to interpret the CAD that you provided to machine against. The tolerances that you need to call out in a modern drawing are usually those critical ones. So the tighter tolerances or anything that is critical to measure. Everything else is dictated by that CAM program. And the title block kind of covers the rest of that, if you will. And as we all know, just please, when you are submitting this package of CAD, drawing, and your specifications on the Xometry quote, that's your love letter to your manufacturer. So they're seeing exactly what you're submitting, that exact that information, that CAD data, what the drawing is, And so we are going to read that explicitly, and that's going to be the the course that we're going to take on manufacturing your products. So just making sure those match each other, the drawing matches the CAD. There's no revision changes between those two. It's very, very important to, again, make sure that we don't have an UPSI or something that could delay your project down the line. I'm just, because I mentioned this, so again, like this is very common to use a title block, usually 3 decimal points for 5,000s, 2 decimal points for 10,000s, when you're talking about machining metals in particular. But this will help cover a lot of those general spot measurements without the need to fully dictate as if I'm just using a drawing without CAD and making a design. And I'm gonna volunteer Mark again for this, but yeah, so for everything else, you have your critical distance tolerances, but a lot of times we could also consolidate some of this and simplify and usually make your part work better in reality, especially if it's being assembled into other stuff by using things like general or geometric dimensioning and tolerancing.
Yeah, absolutely. And I will warn straight off the bat that this is not going to be a comprehensive tutorial about how to use GD&T. This is just kind of like an overview and an application-specific perspective on how GD&T works when you're communicating with manufacturers. So GD&T stands for geometric dimensioning and tolerances, and like Greg mentioned earlier, when you're communicating with manufacturers, you really want to write them a love letter, and GD&T is a tool that can help make that love letter, super precise, or it can, or if you use it incorrectly, it can be something that scares your manufacturers away if you overuse it, or if you use it in a way that actually adds complexity or something like that. So when you are working with GD&T, you have to make sure that you're familiar with exactly what you're saying. But to give you an overview, GD&T is basically a way to more precisely call out your tolerances. So it starts with datums. Datums are generally faces, planes, axes, cylindrical features on your part that are used as references. So that's kind of where you're going to be pulling measurements from. And basically you are tolerancing features relative to those datums. GD&T is really important because I think we talked about this a little bit earlier, but parts don't exist in a vacuum. Everything that we make is physical, it's tangible, it's going to get delivered somewhere, it's going to be part of an assembly, it has to work as designed. And GD&T is what you can use to ensure that your parts made together properly, that they interface with the right, kind of mechanical properties that you're expecting. I think the next slide goes over some of the.
Yeah, and I just want to say also, when we talk about datum A, B, and C, what is so great about using datums, even in a lot of regular drawings, like if you have some or some GD&T, or maybe if you don't, those datums are how we're setting up the machine setup. Like we are planing datum A to make sure that that's definitely flat, and we're going to reference everything off of datum A, and we're using that for a reference from the machinist. You're using it as a designer to reference all your dimensions off of, and our quality assurance team, so our QA team, those inspectors, are referencing it on as well. So when we get on if we have to get on the phone and talk about this, when we say A, everybody knows exactly what that is. So just in general, GD&T is a much, much better way of communicating your part because every single party knows exactly where that is and what we're talking about.
Yeah, that datum choice can be very, very critical. It can have a pretty significant impact on how a machinist will go about manufacturing your part. Because everything is being measured relative to datums, like Greg said, normally they're some of the first features that are machined. So you have to keep that in mind when you're actually going through and tolerancing out your drawing as well. You don't want to choose a feature that's going to be one of the last features to be machined and set that as a datum, because then you have to measure everything that was previously machined to that datum. That's not always the case. Sometimes that would make sense, but you just have to keep that in the back of your mind.
Yeah, and again, like as Mark said, we're happy to brush on some topics, some application topics in the Q&A. A GD&T course is is a week-long course on itself, but just understand that it is a very powerful communication tool. True position is great for things like if I have a 5-array hole and it's going to mate with a 5-bolt setup on another part here, I'm going to be using GD&T to make sure that array is all relative position to each other to make sure that they mate up correctly on the other side. So again, these are usually used when parts are mating or assembling with each other in some way, shape, or form. I made this little slide because at the same time, I like saving costs on my design. So anytime you're adding some of these tolerances like position or especially things like profile, surface, you may accidentally or intentionally dictate a measurement method that's going to add time and expense. We use coordinate measuring machines for profile tolerances, for example, so to measure those surfaces or measure those lines, and that'll instantly add hundreds of dollars in a few days lead time to a part, but you're going to get the accurate measurement that you're looking for on that call out. So just understand that you can constrain a lot of stuff, and definitely don't do a surface profile at the entire part of 0.006, and that this leaves some bad days to you. There's much better methods for that, but you can but just understand that those can drive costs because it will start to dictate how I need to manufacture and how I need to inspect those features down the line. So what some of my tips for avoiding over tolerancing in general is you can always use some level of clearance. So if you do have a hole that actually has to be there, but everything else is relationed off of that, kind of like an anchor point, sometimes using designs like slots can help really loosen up the tolerances while getting your mechanical intent, like the assembly intent out of your design. You also don't want things like the width of a counterboard to be your failing point, right, on a part. So just making sure that clearance is designed in, and using gaps and clearances to your advantage. If you have a full flush, multi-planes are flushed together on your design, understand in reality there's going to be some wiggle there. You may see like a lip seal that's bulging out on one side, even though it's in tolerance. So by building in clearance and designing in clearance, and only having those features that want to be made flush together, you're going to actually have a much more repeatable, more manufacturable design, and you're just going to like the results better. Ooh. We do not want to remove my computer now, Adobe.
Great.
All right, Adobe's taking over. The other thing I was going to say is sometimes you could actually put tight tolerances on a couple features, like an index feature, a keying feature, or even dowel pins. Dowel pins are super cheap to buy, and they're extremely precise. They're a great way to line up parts together. And again, that means you don't necessarily need to over tolerance a bunch of features to fasten. You may be able to just do 2 or 3 pins and make those very tight and be able to couple up your parts, and then everything else can be a little bit looser. You still get the exact same mechanical result. So I grabbed this from CAD here, and actually, Steve, I'll talk about this, but I know we have a great example right after the slide about why this is important here. I'm using a CAD wizards a lot for what I communicate specifics on holes, and this is a question that we had, which is how do I communicate specifics on holes, tapped holes, countersinks, counterboards, blind holes. What I like about using CAD is the fact that it does kind of autofill some of this for me. So it takes some of the guesswork out. But in general, here's the stuff that I'm looking for, right? So I'm looking for that drill diameter. We don't want you to model in the threads. We actually would rather have the hole at that minimum drill size because I'll give you an example again in a second here, but we can't make a hole, we can't make holes smaller. We can always drill them out bigger. So just making sure that you're using that minimum drill diameter for those holes. We want to kind of see what, not just the thread, but the actual class. And even these type of features here will tell you like how we're going to inspect this. We want to know the depth of a thread. So for example, this little feature here, kind of like the line and down arrow, is telling me the depth of or depth of the hole, and then depth of the thread here. So I know that the hole goes this deep, and the threads will only go partially. We also always want to see this type of setup. We don't want to see the threads go all the way to the bottom of a hole, especially a blind hole, because taps typically are tapered. So there will always be an incomplete thread at the very bottom of a blind hole if we're fully tapping it through. And so you always want to kind of over drill that area or design that in and only thread what you need. I know, Steve, we were talking, I think you were saying like 1.5 to 2 times diameter is usually the amount of engagement you need for threads in the first place for fastening. Is that right?
Yeah, it's about right. About 1.5 times diameter worth of thread will give you pretty much the max thread strength. So try not to, put holes that go all the way through. That's just added time for manufacturing if they're not needed to be.
Yeah, exactly. And that's kind of this example here is kind of showing a full through thread. Usually when I see that, it's more for things like optics, like things where I have an adjustment knob that needs to remain really precise. But yeah, if I'm putting a thread in, like screwing a piece together, you don't need that much thread in reality to actually get full engagement. Just another note I brought up before, but things like countersinks and counterbores. So you can see the counterbore symbol here, the countersink symbol here. I usually keep that as a 2 decimal tolerance because it's okay for those to be a little bit looser because they're there to accommodate the head of the screw. So don't let the counterbore width tolerance be the reason for your part being delayed due to rejection. So it's okay to be looser on the tolerances there, but obviously the drill tolerances can be that 3 decimal point. So yeah, Steve, talk about, so this is
All right, so
a real life
this is an
example.
example. This is an example how not checking what you're tolerancing can cause delays. So I got an email the other day. This manufacturing partner had this 4 times call out 332 through, and then tap 3816. Luckily, he caught it. The actual tap drill size is about 312.5 to 313. So basically, I had to put them on hold. I had to go to the customer and find out if they really needed that. And what I found out is they basically snapped on one of the pitch diameters inside the modeled thread instead of the actual minor diameter. So if they wouldn't have reached out to me, this could have been a scrap part very quickly.
And that's because, so you see what you see on your essentially tap and clearance drill size lookup charts, which are
Correct.
all very standardized. So you see that 313 there. And if I'm just designing this from scratch, I may put a 313 hole through and call it a day. If it was 332 though, we're going to be measuring on our tap tolerance chart here at 321. So a hole that big will already be out of tolerance. And in reality, if I ran a tap through that, at best, I'd have about 50% resolved threads on that. So it'd be like a very, very coarse thread to that. So this is more a cautionary tale of probably in the design it was okay, but when when the drawing was being generated, they clicked on the wrong edge. So it's just very good to always double check on your design and on your drawing and just make sure things are okay. The good news is a lot of machinists have tapped some of these standard holes so many times that a flag does raise mentally because they're kind of used to they're like, yeah, 3125. And if they don't see it, or if they don't see a 313 and they see that 3/816, we don't want to rely on that, but we do catch stuff like that because we're so used to this type of work. So the next question, we had a question about bearing tolerances, but we want to talk about fits first. And just briefly, I know there's a lot more categories than just clearance and interference, so I kind of dumbed this down, but let's talk about, bearings, shafts, and fit tolerancing in general. Mark, you
Sure.
want to take this?
So just to start, all parts in an assembly have to interface somehow, right? And the two kind of broadest types of assembly fits are clearance fits and interference fits. Clearance fits would mostly be used for fasteners or parts that just need to be located. Interference fits, the first thing that comes to mind for me are just things like dowel pins. And there's been a lot of engineering precedence for how to design fits. If you generally work, depending on what unit system you work in, there's ANSI standards that define fits. They go from things that are described as like loose or free running to positional fits, which are a little bit tighter, to force fits, which would require that a mating part be pressed in or either heated or cooled to assemble properly. And then on the metric side, there's an ISO standard that defines how to call out and specify your fits. So there's in the machinist handbook, or in manufacturer's reference guides. There's a lot of precedents that you can pull from to teach you kind of how to design these fits. But one of the ones that we see most commonly with parts we're manufacturing are, how do I design my part properly so that I can press fit in a bearing or a bushing or something like that? And it's a really good question. It's kind of Pandora's box. You have to be careful with it, because in general, the manufacturer for the particular bearing or bushing that you're going to use will have an applications guide where they will give you, not only information about the lifetime and proper load conditions and things like that for the bearings, but they'll also give you guidelines on how exactly mating parts should be manufactured. So if a ball bearing is being pushed over the outer diameter of a shaft, what is an acceptable kind of tolerance range for the shaft if it's going to be pushed into a circular pocket and retained on kind of the outer race of the bearing? What size should that pocket be sized at as well? And the one thing I'll warn about is that for bearings especially, and it depends on the size and design and application of the bearing, but there can be some very, very tight tolerances required. Sometimes we're talking about tolerances that are in the tenths region, and generally Xometry's tightest tolerances are like ±1. So if you can get away with allowing us to ream bores for bearings, that's a really good low-cost option to properly manufacture kind of a bearing interfacing fit. But sometimes you have to be careful, because proper fit with a bearing may require grinding or honing or lapping even, and those different manufacturing processes definitely wouldn't auto quote on our site. So it's the type of thing that you'd want to work with your Xometry account manager and like an applications engineer to properly quote. But in general, the manufacturers for any off-the-shelf bearings or bushings or anything like that, they will have full manufacturing guidelines that you can reference.
Yeah, and this example is actually from GM&T bearing, but I like their calculator a lot, so I'll give them mad kudos for this. But this is, they make bearings, they have a bearing calculator that you can input to see how you would tolerance this based off their specifications. And notice that there, right? This is extremely tight tolerancing. If I am using this bearing design for like a landing strut or something, absolutely 100%. Talk to Mark. That's what Mark's team is for. Like, that's literally what they do all day long. Is that, we make sure that this is right, and usually that we have the right manufacturers lined up to do that job and inspect. Again, not just do the job, inspect the job, so that we have confidence in the production of this. That being said, if I'm a university robotics team, I may be okay with running a reamer through at that 22 millimeter diameter, because that's still like 5/10. It's still extremely tight tolerances, and then press fitting that in and having, I would say, a 98% confidence of the function of the part. So there's what the manufacturer says. And again, if you're working in major critical applications, absolutely tolerance this, talk to us, we'll get the quote out. But if not, you could save a lot of cost driving factors by saying, all right, doing a ream is okay. So the other question that we get a lot, because we do more than just prototype cuts, right? We do full spec manufacturing, and we include finishing in our services. So our tolerances applied pre or post finishing. In general, we are measuring parts before the finishing service is done. So that is going to be checking the tolerances per your drawing before finishing, and then it's going to go out to that, the plater, painter, anodizer to do the secondary operations of those parts as secondary finishing. If you do have something, so say you have a dovetail mount or something that's very tightly toleranced, and the dimensions need to apply after finishing, this is where that love letter to Xometry, to your manufacturer, comes into play. Make sure that you're explicit in the notes, so tolerances apply after finishing. That's even worth noting if there's specific tolerances, that you're noting those actually on an arrow call out on those features on your drawing there. The other caution that we have when we talk about finishing is with threads. So unless the drawing says mask, we are going to be running that anodize or plating operation against that whole part. So when you have threads in your part, that means that those threads could actually be essentially coated or have been overgrown, so there may be an interference in their fit. So it's really important, again, to either note for a mask or let us know about this beforehand, because I think, yeah, Steve, there's like compensation taps that you can use for things like that.
Yeah, especially for like hard coat, because hard coat can add up to thousands per side. So, you know, if you need a 2B thread size and you want the hard coat down in there, then there's a special tap that has to be bought and used on that to allow for that coating to coat correctly to become in spec at the end.
Yeah.
So there could be excess tooling costs.
Yeah, so hard coat's like a type 3 anodize, and type 2 anodize you could kind of get away with. In theory, it doesn't add buildup, but I could tell you from experience, it's still a little tacky. Like if you're trying to make a thread in, so you may need to work it on the part. But yeah, just something to be generally aware of when and how you're tolerancing, especially if you have something that has a post finish tolerance, to make sure that you're letting us know. And of course for those masking. Other question. In fact, I actually just saw a question today. So a question from a customer or from a attendee of this webinar, as well as a question that just came into our FAQ today. But this, how do I call out edge breaks, deburring, and how do we inspect it? And Steve, actually, I was wondering if you could run through this.
Yeah, actually, when you're calling out edge breaks, if you need a specific edge break, try and put a note on the print, especially if it's like a cosmetic part, and you want machined edge breaks, so everything's even and uniform all around. Try to stay away from radiuses as edge breaks, just because it can drive the cost of manufacturing up as well as the time to manufacture. And try to put a tolerance on there as well if it's something that's really important to your design, because otherwise it can just be interpreted by the manufacturer that's actually putting them on there, whether they do it by hand, machine, or so it's good practice to make sure you have a note in there about edge breaks.
Absolutely. So most of the time, the question is almost reversed. So if, for example, like we deburr all parts because we don't want you to pick your part up and cut your hand open, and so and sometimes that deburring is done via cam, so a finishing pass on the part to help remove burrs around the corners. Something that's done with a manual deburring tool. So this is kind of like a little tool, a curved blade that you run around your part to remove some of this these excess burrs. If your inspection team has rejection criteria around that, so a lot of times like not to exceed 30 thousandths, 45-degree chamfer is a pretty common one. That's something that should live on your drawing in the notes somewhere, because we're going to make sure that we're going to be hitting that. We're definitely not going to be whittling into your part. There's still workmanship standards that are standard across the industry. But if you do have rejection criteria on your side, it's very good to define that. If not, we're going to run with basically a standard practice, for those shops. So whether it's going to be a hand tool or just running in the cam, whatever their signature is. So I've been Serena, I'm pretty excited. I've been seeing a bunch of questions coming in, so this is very exciting here. QA a couple minutes away. We have a couple announcements to make. But please continue submitting your questions, and this is I think where this team just really shines. Like I said, I could geek out with these guys all day long on this. And in general, we do have FAQ on our site at all times. Support.xometry.com is our FAQ site, as well as some tremendously good guides, so design guides. So if you're looking for CNC machining, we have a design guide for CNC machining under our resources page. A bunch of videos that we've done on these subjects as well. But our live support team, so support@xometry.com, will catch everything. If it's a purchase order, we take it. If it's a question, we'll take it. It'll get routed to a pre-sales engineer. If you've quoted on our site, or if you're quoting on our site right now, you may actually have already been messaged by one of your dedicated account representatives. So you could also directly talk with your account representative, and they're your sword and shield to help escalate. But just understand there's a lot of ways to contact Xometry, and we're here because we want to make your project a success. So ask us questions. We're here to help work with you. You're the designer here. We're your manufacturer of choice, and we want to make sure that relationship's just awesome. And we got a little code, right, Serena? Oh, you're muted too. Oh no, Serena's muted. All right. We got code instant 50. Like this is me. But yeah, we got it. There you go. You're back on.
Hey, sorry. Yes. Been doing that too much working from home lately. But guys, thanks for staying on. We have this code instant50 caps lock for you to use on your next order. It expires next month, so use all of your DFM knowledge from today towards your next order. And this code.
And definitely, it's a good excuse too. If you haven't used Xometry side, upload a part. I didn't get a chance to show you that, but I mean, when we talk about instant quoting, it instantly happens. You get a price right away. So it's just, and that's actionable price. You can go ahead and purchase immediately. So doing price checks or ready to buy, either way, give our site a go. So yeah, let's start looking through some questions here.
All right, so let's start off with how can you provide an example of modeling to nominal?
Yeah, I could talk about that a little bit. So if I have a, let's say I have a 1-inch block, or like a 1-inch cylinder diameter, and it is actually fitting into, it has to have like a loose fit into a hole that is 1 inch, right, or like 1.001. I may want to put a not to exceed 1 inch on that. So the way that I would tolerance that is a +0, and then let's say minus 10 plus, so +0 minus 0.010 to that. So the cylinder, if you model that as 1 inch, if I was just milling it, I may have risk of having interference just by natural wiggles and kind of on the actual machine process. But if you actually model that in the middle, so if you model that cylinder at 0.995, you could still make your dimension call out saying 1, +0 minus 10, but that would be an example of modeling to the nominals there. So the actual CAD would be 0.995.
Awesome. And what about measurements for drawings? We have one attendee who's from Canada. Can parts be specified with metric dimensions, or should they be converted to inches?
We work with both.
We'll take everything.
We live and breathe with 25.4 on our heads. And honestly, by the way, I've worked at additive manufacturing for over a decade. Everything additive manufacturing is in millimeters. So like it's just second nature for us. Yeah.
I've worked with a lot of customers that are transitioning from using inches, that are trying to transition to using the metric system on their drawings, and it's perfectly fine. The one thing that I will warn against is don't mix unless you are going fully dual dimensioned. Like if I see a drawing that has everything dual dimensioned in metric and inches, millimeters and inches, that's fine. It's pretty helpful, but be careful not to mix. And sometimes this is tough, especially if you're working with engineers that are transitioning between two systems. If you're going to use the metric system, that's great, but make sure that every single thing on the drawing is at least primarily dimensioned in the metric system.
And this is actually very good. Also, when you're talking about those title block dimensions as well as tolerances themselves, the huge difference between like a 0.008 millimeter and a 0.008 inches. And I was saying that because when I was doing that bearing example, I was like, oh, 0.008, that's pretty loose. And then Steve pointed out that's millimeters, Greg. And I was like, oh, never mind. That's ground. Yeah.
Yeah. you know, most of our machinists, we have manufacturing facilities around the country, but most of our machinists in the United States, they're most comfortable working in inches. You know, they kind of have an intuitive feel for what a few thou is, more than what 0.008 millimeters is. Doesn't mean you should choose either one, but the other thing that I'll say is that if in either case, whatever unit system you are using, I do love when customers make it very, very clear on the drawing block. If it's metric, it says in very big block, bold letters, this is a metric drawing. If it's, you know, an ANSI standard or something like that, that's stated as well. Clarity is key.
Yeah, absolutely.
Awesome. And can you guys speak to the rules for evaluating parts in IQ? The analysis of curved surfaces or a comparison of parts. I think this question is saying that
instant quote, I think. Yeah, I think this is about instant quoting. So I'm guessing, I'm interpreting, if I interpret this wrong, I'm so sorry, but I think this is about instant quoting. So we look at a lot, and our model is a little bit different where we're actually doing something called market-based pricing. So we actually use AI and machine learning to say parts like this on an open marketplace will cost this much. And that's the price that you see. So it's a little bit different than if you are taking out your spreadsheet. If you're a machine, like a machine shop, and you've done this in the past, you take out your spreadsheet and you start typing in the amount of features and things to it. Obviously, major cost drivers for, you know, if you're typing that spreadsheet, tend to be major cost drivers for market-based pricing. But there's actually many more factors than just the net manufacturing of the part that come into play. And we found this model to be very good at producing accurate pricing that also pays machine shops well. You know, like, so it's low cost for you. It's serviceable by our machine shops because it hits their sweet spot. And we've been able to have just a really awesome feedback loop to, you know, make quality parts at low cost and quick lead times.
Okay, great. And a couple of you asked whether this presentation will be available. It will. Tomorrow we'll send out the on-demand recording as well as the slide deck. Next question, if a group of parts require the same finish, i.e. a powder coat, can quoting be treated as a lot price?
Yes. So things like black anodize and stuff like that will automatically share on the quoting side. So that happens auto-magically, if you will. One thing to note is if you are, say you're building something like a keychain and you need, you know, 3,000 of them, give us a call. Talk to Mark because we may want to manually adjust that out because there's assumptions made on racking for basically when you're doing these coats like powder coating and other things, you're hanging the parts. It's called racking, and with super small parts, you could pack so many in at once that it's worth us doing a manual review of that.
All right.
It'll save you a lot of money.
And next question, when you have mirrored parts, how do you combine for a quantities price break if you haven't already covered that?
Actually, Steve, do you want to talk about this? So the manufacturing of mirrored parts, like how much of that is shared as far as setups go?
I'm not really sure how our system figures that out. On the manufacturing standpoint of it, you essentially only have to program the part once, and then you can mirror it. Now there may be different fixtures involved, and it's more on, you know, the individual part itself. But that would probably be something that would want to talk to our manual quote team about.
Yeah, our auto quoting system won't capture that parts are mirrored and could share setups and fixturing and programming and things like that. So if you do have mirrored parts, I don't know if we've gotten to it yet today, but you can always start with your account exec if you have questions like that, and they can do a review of your quote. If your account executive hasn't made themselves known to you yet, I would be very, very surprised. But you can also always email into, we have kind of two emails that would come into my team. My team's responsible for doing manual reviews of your quotes for things like the exact kind of things that are coming up in most of these questions. And you can either email support@xometry.com or quotes@xometry.com.
Yeah. And just to note that unique fixturing is still a large cost driver. So even if the part's mirrored, like your fixturing doesn't automatically mirror itself too. So anytime I'm work holding a part, especially second op and beyond, I usually am custom cutting what we call soft jaws for that. And so a lot of that's not repeatable. So you may find like that a mirrored part for, especially if you're just doing like a smaller set, like it doesn't really save too much cost between each other, just because they're still, you know, they're still unique setups in themselves. There's still physical goods being made just to hold that part.
Okay. And is there an as-built drawing feature for machine components?
So, okay, so are you talking about, I think this may be talking about just running our general tolerances and how do I still need a drawing for my ERP system, right? So I cannot release a part without a drawing. That being said, as built is there. So that's where your title block comes to play. You know, I think it's a very good one. So you could have this and you can have this and put something like dimensions for references only. This is more common in stuff like additive manufacturing, really, but turning everything into a reference dimension, so those dimensions, those parentheses around it, where it helps us for spot checking, but it's not necessarily rejection criteria against those parts. If I did not answer that question well, shoot me an email and I'll make sure to answer that. But that's my interpretation is, you know, I need a drawing because my ISO standard says every part needs a drawing. That being said, I actually don't really need to tolerance it. You know, so title blocks are fine and reference dimensions are great.
So it's kind of antithetical to the whole reason that we're having this webinar, but we don't need a drawing to manufacture your part. If you're okay with, Xometry has manufacturing guidelines for all of our different processes, like Greg talked about earlier. For machine parts, that is generally plus or minus 5 thou on all features, a surface roughness of 125 microinch RA. And if that's all you're looking for, you don't have any threaded holes, you don't have any surface finish requirements or anything like that, you certainly do not need to upload a drawing onto our site. We can work off of just the CAD model.
Great. Let's talk NDAs. How do customers get that in place? And let's start with that, with this from that person.
Yeah. So I get to cover the NDAs, and I'm sneak previewing. I'm looking at the questions, and then Mark will cover the next one probably. So on NDAs,
I should look at the questions.
I'm cheating here. On NDAs, we do NDAs all day long. So everything, first off, inherently, if you upload to our site, we are treating 100% of our customers' work with confidentiality. We wouldn't be in business if we aren't doing that. So we're going to be treating your work. Your work is uploaded on a secure system. It is like we have an entire cybersecurity backbone, like kind of upholding that side of the business. And your parts are to your specific login and identification. Your quotes are your quotes. Your parts are always your parts. If you want to execute an NDA, you could talk to your account lead or contact support, or go to do some self-service. Go to our FAQ page. So support.xometry.com. Type in NDA. And you will find a link there where you can actually download a mutual NDA that Xometry has, fill it out, send it out to us. We'll send you an executed copy back, have that in place. Or you could email your own NDA to support@xometry.com, and we'll take care of that for you. But it's NDA, vendor forms, you know, all the bureaucratic work. We do that all day long. We have specialists for that. So we're really here to help and facilitate, because we work with, you know, everything from, you know, major organizations down to individual inventors and beyond. So yeah, we have all the resources for you.
Awesome. What about, and then this question continued from this asker. Do you offer heat treat, and do you have a listing of other finishes you support?
Yes, absolutely. Right on the quoting site, you can choose from a somewhat limited number of heat treatment options. I think it might be limited to just case hardening and through hardening, for example. So a few caveats with this. So a lot of heat treatment, heat treatment can either occur on raw material before we start machining or on finished product after machining. And then sometimes, we have to even go through interim heat treatment steps, either stress relieving or hardening, and then final machining if tolerances apply after heat treatment and things like that. So my recommendation would be for the most basic heat treatment operations, maybe you just want a steel part through hardened to like 50 Rockwell or something like that. That's perfectly fine to auto quote. If the heat treatment operations get more complicated, and I run into this a lot in our aerospace applications. Let's say, for example, you're working with 15.5 stainless or 17.4 stainless or something like that, where there's a number of different kind of grades of precipitation hardened material that parts can be manufactured from. I would generally, in those type of situations, opt for either a custom material or a custom finish when you're building the quote. And then you can, I don't think we even touched on this yet, but for all of the different materials and finishes, you can always select custom on our quoting site. And what happens when you select custom is then there's a button in the top right. You can click request a manual quote, and that quote will come into my team of manual quoting engineers who will review it. Heat treatment is it has a lot of nuance to it, different kind of edge cases, and it's definitely something that you'd want to get some human eyes on to make sure your quote is accurate before we go too far into it. But no, we can certainly offer heat treatment. To touch on the second question, do you have a listing of what you support? So it's a really, really good question across the board for how Xometry operates. Obviously, we offer everything that's available on our auto quoting site, and we kind of hinted at it earlier. We offer a lot that we don't auto quote in terms of custom materials and custom finishes. There are definitely very, very specialized processes. Maybe there's only, the type of thing where there's only like one vendor that will do a particular trade secret finish or something like that. In some situations, we won't take on the most difficult, most custom finishes that we don't have a lot of experience with. But for the most part, if there is an industry standard like an ISO or a MIL or a Fed standard spec or something like that that defines a finish, and it's something that's relatively commercially available at a number of different finishing vendors, because we have such a huge partner network, it's almost always something that we can quote.
Yeah, we say yes to a lot.
Yeah, we say yes to a lot. Yep.
And so yeah, like I said, the instant quoting is going to get you, as Mark mentioned, instant quoting is going to get you to, I think, 95% of your regular projects. If you have specialized finishes or even a material, we have a custom option for material. Just write that in. Because we still use this as essentially the transmission venue for you to talk to our experts. Mark's team itself they're like a team of Steves. Like it is a team of experienced manufacturing experts in different fields. So sheet metal, machining, additive manufacturing, injection molding, and they're able to take a look at your requests, have some dialogue with you if needed, and make sure that we're fully specifying what you're asking for on this. But we have this manufacturing network in US 3,000 alone, and that's a lot of capability. Believe us, we have access to it. So it's it's a very powerful tool, and you still have the convenience of that upload specification and using Xometry's full distributed system.
Okay, we do have a couple more questions, but we're almost at time here, and we're going to ask probably 2-3 more. And if we don't get to your questions, please feel free to follow up. Your engineers' emails are here on the screen, and then they will also follow up for any particular project questions as well. So one thing we had talked about in the agenda was whether the digital thread will change manufacturing. Can you guys touch on that?
Yeah, I could definitely say, I've been and I think Steve, you've been in this, and Mark, you've been in this to some degree, but we've been both buyers and suppliers in our life, and I've been through the pain of procurement, right? So that whole that whole just waiting, and I'm just following whatever my vendor SKU says it was last bought by X, and I'm going through and I'm putting in that information, and there's so much downtime, there's so much waiting there, and there's so many questions, and even when you get to a quote, very often like these quotes from all these different manufacturers, they may be making assumptions, or they may be charging for something that is not there, or they may be embedding a charge that you're not aware of. Sites like Xometry's really bring transparency to what you're agreeing to buy. To what you're, it helps standardize that format in which you are presenting your quote. It speeds up, again, nearly, in some cases, it's just kind of a buy it now experience, like an instantaneous process. And it does that vendor selection dynamically. Like it actually is it's working to get the best pricing and connect those manufacturers to you. It is we're a supply chain in a box. So like there's this digital backbone to it, but like that connection, really what it does is it takes this whole complexity, nuances, and opacity of a supply chain and just simplifies it to a click and buy experience. There's still a lot that I want to see, but it's a lot better than 6 years ago. I'll definitely say that. Yeah.
Awesome. And taking it back to our CNC capabilities, can we hold tolerances tighter than 100,000? And
1,000. Yeah.
Yes, 1,000. I am not an engineer, clearly. So can we?
I'll go. Mark's
Sure.
gonna nod and say, "Yep."
Yeah, we can. Plus or minus 1,000 is the tightest that you can select on our auto quoting site. I think most people could understand why we wouldn't want to start slapping prices on parts that have tolerances much tighter than that. But obviously there are a number of situations where you would need tighter tolerances than that, and in those situations, that's where you would request a manual quote. If it's features, for example, that just need to be reamed, and you can find an off-the-shelf reamer for $12 or something like that for dowel pins, those are very, very easy. But kind of going back to the conversation earlier where we were talking about bearing fits and things like that, tighter tolerances could dictate a move to a different manufacturing process. You could move from traditional CNC milling or turning to surface grinding or cylindrical grinding or lapping or honing. And so we can certainly hold tighter tolerances than plus or minus 1. I would say that I would give the caveat that Xometry is, what we capture in terms of the manufacturing market is probably like, I'd like to say around 90% of what is possible. But if you do have incredibly tight tolerances, then generally you should start looking for a specialty manufacturer. But the tighter tolerances than plus or minus 1 are certainly feasible. We manufacture shafts all the time that have 6/10 tolerance bands on them. It obviously all depends on exactly what you require, but with a manual review, we can generally quote tighter tolerances.
Yeah, and I also, by the way, there's a bonus question. Someone's asking about ISO 2768. We dance all day there. So GD&T, these ANSI ISO standards, we live with that. So absolutely, because we have such a large customer base, that we're reading your drawings, and we have even here at Xometry, we have internal QA and QA specialists, including people like Steve we're reading, we're interpreting those drawings, and we're measuring and inspecting your parts to those standards.
Great, and let's close it out with one last question. Generally, do you guys have tips that a designer should follow when creating drawings regarding tooling sizes or otherwise?
So I would actually refer to one of our ways to save on CNC machining. We have some videos and webinars on that, as well as the CNC design guide. but there's great drill depth ratios requirements. So like about 1 to 8 to 1 to 10 for a drilled hole, about 1 to 4 to 1 to 6 maximum for pocketed hole. Making sure that the corner radii that you're making are actually a little bit above a standard drill size, so that I could actually zoom around those instead of having to butt up to the edge on internal pockets. But you're going to find a lot of tips and tricks on some of those. And I'll look for your question. I'll find your email. I'll shoot you some references as well for that. But those are all under Xometry.com. Go to our resources tab. You're going to find some great guides there.
Awesome. Well, thank you everyone for attending this webinar. Thank you, Steve, Mark, and Greg for sharing your manufacturing expertise. Please feel free to follow up with them if you had questions that were not answered or have further questions. And do you guys have any final words?
I'd like to thank the team. I mean, honestly, just putting this together, I'd like to thank the folks who submitted their questions. We love talking about this subject. I hope we do more of this. Yeah, because the Q&A is where we really excel. And yeah, thank you so much.
Yep. Thanks for all the questions.
Awesome, guys. All right, have a good one. Thank you again.